Section 700.1 defines an emergency system as a system that supplies illumination, power, or both for illumination and power. Section 700.6d addresses transfer equipment and states that the transfer equipment shall be suitable for the intended use and shall be designed and installed to prevent the inadvertent interconnection of normal and emergency sources. The core issue revolves around whether it is permissible to connect both emergency lighting and cash registers, specifically in a food store scenario, to the same transfer switch. The answer lies in a careful interpretation of the National Electrical Code, particularly Article 700, which governs emergency systems. The key is to ascertain whether connecting both types of loads complies with the code's intent to ensure reliable power for essential functions during an emergency while preventing any hazards. A transfer switch is a crucial component in an emergency power system. Its function is to automatically switch the load from the normal power source to an alternate power source, such as a generator or battery system, when the normal power source fails. This ensures that essential equipment, like emergency lighting, continues to operate during a power outage. Now, regarding the connection of cash registers to the same transfer switch, the National Electrical Code does not explicitly prohibit it, but there are specific requirements and considerations that must be met. The primary concern is that the transfer switch must be appropriately rated to handle the combined load of both the emergency lighting and the cash registers. This involves calculating the total current drawn by all connected devices and ensuring that the switch's ampacity is efficient. If the transfer switch is underrated, it could overheat, malfunction, or even fail, rendering the emergency system ineffective. Firstly, the transfer switch must be listed and labeled for emergency system use, according to UL 1008 or equivalent standards. This listing ensures that the switch has been tested and certified to meet specific performance and safety criteria for emergency applications. Secondly, the transfer switch must be capable of automatically transferring the load from the normal power source to the emergency power source within the time frame specified by the National Electrical Code, typically within 10 seconds. This ensures that emergency lighting is quickly restored to provide adequate illumination for safe egress. Thirdly, the transfer switch must be designed to prevent the inadvertent interconnection of the normal and emergency power sources. This is crucial to prevent backfeeding, which could damage equipment and endanger personnel. Fourthly, it is essential to consider the nature of the cash register load. Cash registers are electronic devices that typically draw a relatively small amount of power. However, they are critical for business operations, especially in a food store during a power outage. Customers may still be present in the store, and the cash registers are needed to process transactions and maintain order. Fifthly, emergency lighting is paramount for safety during a power outage. It provides illumination for customers and employees to safely exit the building. Emergency lighting systems must comply with stringent requirements, including minimum illumination levels and backup power duration. Now let us delve deeper into the relevant sections of the National Electrical Code. Section 700.1 defines the scope of emergency systems, stating that they are intended to supply illumination, power, or both to specific areas and equipment when the normal power supply fails. This section highlights the life safety aspect of emergency systems, emphasizing the need for reliable power to ensure the safety of occupants. Section 700.6d specifically addresses transfer equipment. It mandates that the transfer equipment be suitable for the intended use and designed and installed to prevent the inadvertent interconnection of normal and emergency sources. This section underscores the importance of selecting and installing a transfer switch that is appropriate for the specific application and that prevents backfeeding. To ensure compliance with the National Electrical Code, a qualified electrical engineer or licensed electrician should perform a load calculation to determine the total demand of the emergency lighting and the cash registers. This load calculation should take into account the inrush current of the devices, which is the momentary surge of current that occurs when the devices are first energized. The transfer switch should be sized to handle the inrush current without any adverse effects. Moreover, it is crucial to coordinate the installation of the transfer switch with the local electrical inspector. The inspector can provide guidance on the specific requirements and interpretations of the National Electrical Code in the jurisdiction. The inspector will also conduct an inspection of the installation to ensure that it complies with all applicable codes and standards. If the load calculation shows that the existing transfer switch is not adequately sized to handle the combined load of the emergency lighting and the cash registers, a larger transfer switch will need to be installed. Alternatively, the cash registers could be connected to a separate transfer switch or an uninterruptible power supply. An uninterruptible power supply is a battery backup system that provides continuous power to connected devices in the event of a power outage. An uninterruptible power supply can be a good option for cash registers because it can provide a seamless transition to backup power without any interruption to operations. In summary, connecting both emergency lighting and cash registers to the same transfer switch is permissible under the National Electrical Code, provided that the transfer switch is appropriately rated, listed, and installed. A load calculation must be performed to ensure that the transfer switch can handle the combined load, and the installation must comply with all applicable codes and standards. Coordination with the local electrical inspector is essential to ensure compliance and safety. The key considerations include proper load calculation, transfer switch suitability, prevention of interconnection, and compliance with local codes. It is also important to consider the criticality of the load. Emergency lighting is obviously a critical load as it is directly related to life safety. Cash registers, while important for business operations, may be considered a less critical load. This distinction can influence the design and configuration of the emergency power system. For example, it may be acceptable to shed the cash register load during a prolonged power outage to conserve battery power for emergency lighting. Load shedding is a technique used to selectively disconnect non-essential loads from the emergency power system to extend the runtime of the system. Additionally, it is important to consider the maintenance requirements of the transfer switch in the emergency power system. Transfer switches should be inspected and tested regularly to ensure that they are functioning properly. Battery systems should also be inspected and maintained to ensure that they can provide adequate backup power. Proper maintenance is essential to ensure the reliability of the emergency power system and to prevent any unexpected failures during a power outage. Furthermore, consider the use of automatic transfer switches as opposed to manual transfer switches. Automatic transfer switches are designed to automatically switch the load from the normal power source to the emergency power source without any manual intervention. This is particularly important for emergency lighting as it ensures that the lighting is immediately restored during a power outage. Manual transfer switches, on the other hand, require manual operation to switch the load. This can be problematic in situations where personnel are not readily available to operate the switch. When selecting a transfer switch, it is crucial to consider the voltage and current ratings of the switch. The switch must be rated for the voltage and current of the electrical system to which it will be connected. It is also important to consider the interrupting capacity of the switch, which is the maximum amount of fault current that the switch can safely interrupt. The interrupting capacity must be sufficient to handle any potential fault currents that may occur in the electrical system. Also, carefully consider the type of enclosure used for the transfer switch. The enclosure should be suitable for the environment in which the switch will be installed. For example, if the switch will be installed in a damp or wet location, the enclosure should be NEMA 4 or 4X rated to protect the switch from moisture. Another important consideration is the availability of technical support from the transfer switch manufacturer. It is helpful to have access to technical support in case any questions or problems arise during the installation or operation of the switch. The manufacturer should be able to provide guidance on proper installation, troubleshooting, and maintenance. When installing the transfer switch, it is essential to follow the manufacturer's instructions carefully. Proper installation is crucial to ensure the safe and reliable operation of the switch. All electrical connections should be made by a qualified electrician in accordance with applicable codes and standards. After the transfer switch is installed, it should be thoroughly tested to verify that it is functioning properly. The testing should include simulating a power outage and verifying that the switch automatically transfers the load to the emergency power source. The testing should also verify that the switch prevents the inadvertent interconnection of the normal and emergency power sources. In addition to the requirements of the National Electrical Code, there may be local codes or regulations that apply to emergency power systems. It is important to check with the local authorities to determine if there are any additional requirements that must be met. Local codes may address issues such as the location of the transfer switch, the type of emergency power source required, or the testing and maintenance procedures that must be followed. Finally, it is essential to document all aspects of the emergency power system, including the load calculation, the transfer switch specifications, the installation procedures, and the testing results. This documentation will be helpful for future maintenance and troubleshooting. It will also be useful for demonstrating compliance with applicable codes and standards. Regular inspections and maintenance are crucial for ensuring the continued reliability of the emergency power system. Inspections should be performed on a regular basis to check for any signs of damage or wear. Maintenance should be performed as needed to keep the system in good working order. The inspection and maintenance procedures should be documented to provide a record of the work that has been performed. In conclusion, while it is permissible to connect both emergency lighting and cash registers to the same transfer switch, several critical factors must be considered. Firstly, a comprehensive load calculation is essential to determine the combined demand of both loads. Secondly, the transfer switch must be appropriately rated for the calculated load and listed for emergency system use. Thirdly, the installation must prevent inadvertent interconnection of normal and emergency power sources, complying with Section 700.6d of the National Electrical Code. Fourthly, coordination with local electrical inspectors is crucial to ensure adherence to jurisdictional codes and regulations. Lastly, regular inspections and maintenance are vital for the long-term reliability of the emergency power system. By carefully addressing these considerations, one can ensure a safe and compliant installation that provides reliable power to both emergency lighting and essential business operations during a power outage. Remember to always prioritize safety and compliance with the National Electrical Code and local regulations when designing and installing emergency power systems. Consultation with qualified electrical professionals is highly recommended to ensure a safe and effective installation. Furthermore, staying updated with the latest revisions of the National Electrical Code is crucial to ensure compliance with current standards. The National Electrical Code is updated every 3 years, and it is important to be aware of any changes that may affect emergency power systems. Consider the environmental conditions in which the transfer switch and other emergency power system components will be installed. Extreme temperatures, humidity, and corrosive environments can affect the performance and lifespan of the equipment. Choose equipment that is specifically designed for the intended environment. Provide adequate ventilation for the transfer switch and other heat-generating equipment. Overheating can reduce the lifespan of the equipment and increase the risk of failure. Ensure that the ventilation system is properly sized and maintained. Consider the use of surge protection devices to protect the transfer switch and other sensitive electronic equipment from voltage surges. Voltage surges can damage equipment and cause it to fail. Surge protection devices can help to mitigate the risk of damage from voltage surges. Implement a comprehensive testing and commissioning plan for the emergency power system. The plan should include testing all components of the system, including the transfer switch, the emergency power source, and the emergency lighting. The testing should be performed by qualified personnel and the results should be documented. Develop a detailed emergency plan that outlines the procedures to be followed in the event of a power outage. The plan should include procedures for notifying personnel, activating the emergency power system, and ensuring the safety of occupants. The plan should be regularly reviewed and updated. Provide training to personnel on the operation and maintenance of the emergency power system. Personnel should be trained on how to start and stop the emergency power source, how to operate the transfer switch, and how to troubleshoot common problems. The training should be regularly updated to ensure that personnel are knowledgeable about the latest procedures. Maintain a readily available supply of spare parts for the emergency power system. This will help to minimize downtime in the event of a component failure. The spare parts inventory should include critical items such as fuses, circuit breakers, and relays. Establish a preventative maintenance program for the emergency power system. The program should include regular inspections, testing, and maintenance of all components of the system. The preventative maintenance program will help to ensure the continued reliability of the system and to prevent unexpected failures. In addition to the technical aspects of the emergency power system, it is also important to consider the human factors. Ensure that the system is easy to operate and maintain. Provide clear and concise instructions for operating the system. Make sure that personnel are properly trained and understand the procedures to be followed in the event of a power outage. Consider the needs of people with disabilities when designing and installing the emergency power system. Ensure that the system is accessible to people with disabilities and that they are able to safely evacuate the building in the event of a power outage. Regularly review and update the emergency plan to ensure that it is effective and that it meets the changing needs of the organization. Conduct drills to test the effectiveness of the plan and to identify any areas that need improvement. Foster a culture of safety within the organization. Encourage personnel to report any concerns about the emergency power system or the emergency plan. Create a system for tracking and resolving these concerns. By addressing both the technical and human factors, you can create an emergency power system that is reliable, effective, and safe for all occupants of the building.